Okay, good morning. We're in a lecture today that's going to be covering the following topics. We've got chapter 15, which is coordinates, and then there's another chapter that has layout techniques. So I'm going to be actually addressing these in reverse chronological order. I'm going to start out with layout techniques, control, layout of an arch, layout of the big box, and then the coordinate geometry. So why don't we get started? Hopefully this will make sense. A combination of what I give you today along with looking at chapter 15 probably should give you the foundation you need to attack the test. So layout techniques. You've already used some of this equipment, but I'm going to go back through and give you an idea of the techniques we've got. Layout techniques, a couple of tools we have is a tape, regular old tape measure. We can do a ton of things with that if we use a little bit of math knowledge integrated with it. We've got a transit, which is an instrument that will turn horizontal angles and vertical angles. And we also have a total station. And we don't have those here. We have one or two of them, but we don't have enough to outfit the group. So a total station has the ability of integrating a electronic measuring device with a way of turning angles. So when I lay out something as simple as a building, a lot of times I don't even want to use a transit or a total station. I'll just use a tape measure. Okay, and we'll get into that when we talk about this big box. A tape measure, I've seen people use batter boards to lay something out. Batter boards are just boards that stick up into the air at right angles. So if I was in the field, I would look at them. It would be like little hurdles. And we put nails at the proper position in those horizontal boards. And when we do that, that allows people in the field to take a string between the nails, and ends up with a nice little rectangle. And that rectangle will circumscribe whatever you're laying out. And you can from there have right angles at these corners. You've got dimensions that are controlled by the drawing, and you can go ahead and lay it out. Another thing we could do is we could set up a total station, index it to our control, and then have this total station turn angles and measure distances and lay out corners. So you've got a very wide range of capability between these three, integrating those together, using one all by itself, using two at a time in order to lay stuff out. So don't limit yourself to the fact that if it's an angle, it has to be a transit or a total station. I can lay out any angle in the world, and we have triangles that you probably should keep in your head. I'm sure you know this one from a lot of different sources. A right triangle, a 3, a 4, and a 5. So if I want to lay out a right angle, I can, any denomination of those, like if I multiply 12, 16, 20 will do. So I've got a lot of different shapes, size-wise, that I can do. If I multiply this by any number, I can multiply the other two by the same number and end up with that 3, 4, 5 right triangle. Another one that I use quite often, if I have a structure that's quite a bit longer than it is wide. This doesn't seem to work because those are pretty close. If I took a 5, 12, 13 triangle, okay, that gives me a right triangle. You can see I'm all at 2.5 times longer than I am wide. So if I got a long, skinny building, I wouldn't use this triangle. I would use that triangle. And once again, all we do is multiply. If I got a 20-foot wide building, multiply this by 20, that'd be 48 and 52. I got my dimensions, and now all I do is cross the tape and make sure that those three sides coexist in the right proportion, and I've got it laid out. So our layout techniques are varied. They're project specific. They're also equipment specific. If you don't have a total station, that takes that out of the mix. So when you lay stuff out, make sure that you pick a technique that makes sense to the people in the field who are going to be using it. You're not laying this out for you. You're laying out for the least skilled person in the field that's going to be building it. They got to understand it. If they don't understand it, older guys like these batter boards because they crisscross lines. Now they can set intermediate points and they can crisscross some lines. If I was to put a riser in for a plumbing fitting, they crisscross the lines, and right where those crisscross lines meet, they know right below that is where they're going to have this riser coming up. And then that should fall into the wall when the carpenters get there and frame around it. So that's the layout techniques, okay? Control. We have two types of control. Our control is either vertical or horizontal, okay? Vertical, the elevation has to be right. So where do you get that? So if I'm going vertical control, I'm looking at elevations. The elevation is going to be indexed to some type of benchmark. We talked about that before. The types of benchmarks are going to be a USGS benchmark, which is the United States Geological Survey benchmark, that index to the world, or a site benchmark. Site benchmark is indicated on the drawing by the design team, and you'll know exactly what object on the site is at what elevation, and then you'll index everything you do off of that indexed elevation. Okay, a lot of times they'll use 100.00. Your first floor may be at 102.5. So all you have to do is make sure you've got a site benchmark that you can access easily, that is not disturbable. Somebody can't come out and mess with it and change it and screw everything up. And make sure that that you index off of it and that everything is relative to that benchmark, whether it's the big guy, the USGS, or whether it's a site benchmark. Horizontal control is the position on the ground. Where is it set? Okay, so when you get out there, we're going to have a bunch of different terms, and we'll talk about those later. You're going to have a site of some sort. You're going to have center lines of the road or center line of the right-of-way. You're going to have property lines. You're going to have building lines. You're going to have easements. You're going to have all kinds of control that has to be adhered to because it's law. Okay, so we've got to make sure that we set this building in conformance with the site plan. So the horizontal elevation is going to be a plan view, and it's normally a site plan or a location plan. Okay, site plot. Those are two big words that I've seen a lot. A site plan, a plot plan. Some people call location, which is kind of misnomer. A location plan is normally a little drawing somewhere on the set of drawings that gets you in the right city, in the right spot. It doesn't have much to do with the actual site you're on. So the horizontal control has to do with where you're setting the building. Now, where you set this thing has got to be indexed to something that's non-destructible if possible. I've seen guys go out in the field and play with stakes. They knew they laid it out wrong. They went out in the night, moved the stakes to get it to conform with what it was supposed to be, and then they blamed the contractor because the contractor didn't follow what he was supposed to, and the building now encroached in an easement, was over the building line, and they were going to have to spend a lot of money to change the foundation to meet the local zoning criteria. So you want to make sure that when you lay something out, you've got it indexed to something that somebody can't tamper with. Okay, they can't go out there and move it, change it. redistribute it, okay? So get yourself in a position where you've got notes that tell you, okay, this property corner is indexed to a corner of a building and to a fire hydrant. So I can go out and I can take and run 2 tapes from the corner of the building to the fire hydrant. If I've got the dimensions in my notes and I go out there and that doesn't meet that, it meant somebody moved it. So a lot of this is documentation, and unfortunately that is a glitch of a lot of people. They don't document things properly, and when they get into a court of law, what they did was right, but they can't prove it because they don't have the proper documentation. Okay, that gets basically control. So we've got a spot to put it, which is horizontal, and a height to put it at, which is vertical. So that has all to do with layout. Okay, we're going to get into the big box and the coordinates in a few minutes. This is one next topic, which is an arch, is one that a lot of students give me a call back on, because when you have to lay out something that's a circle and you can't find a radius point, we end up with chapter number 16, horizontal curve. Okay? But what happens if you can find a radius point? It's not that big. You can physically lay it out on the ground. You can physically do it. You can swing an arc. How do you do that without doing what the guys in the field do? You know, we put arches over garage doors. So if I build a house that has 2 garage doors coming into it, one's a bigger garage door, an 18-foot, the other's a 9-foot, and we got an arch over the top of it that looks made out of brick or wood or whatever. How do you go out laying those out so they look like they're an arc rather than some goofy thing? What guys do is they'll lay that on the ground, they'll put a string down on it, they'll move the string around, hose, I've seen them use hoses, they'll freehand it and then stand back and they race and redo it to try to get it to look right. It never does look right. You got a way mathematically to lay this out in a matter of minutes that will allow you to swing an arc and end up with a nice, smooth arc instead of one that's got a bunch of bumps and high points and low points and flat spots. And if you go out in the real world and you look around, you can see them all over the place. It drives me nuts. Okay, so what I'm asking, if I've got an arch going over the top, how do I lay that out easily, mathematically, and how do I physically lay it out so that I can cut it with a saw and have something that looks the way it's supposed to, professional? Okay, to do this, I'm going to use a regular old garage door. They come in 16 and 18 footers. I'll use an 18-footer. And I'll use a 9-footer. Littler garage doors come in 8 and 9 footers. We use 2 garage doors. And let's say that we'd like that arch to be a foot tall. Okay? So if I drew a line from this corner across, and I went dead center, I'd like those arches to match in height and both of them be 12 inches tall. Okay? Okay, so what I'm asking you to do and what the project would ask you to do is, what radius do I swing for those 2 guys so that when I get done, I have an 18-foot wide arch that has a rise of 12 inches in the middle for this one, and a 9-foot wide arch with 12 inches in the middle for that one. Okay, we have a tool available to us. It's called a Construction Master Pro. It's a construction calculator. If you have that in lab, I'm going to show you a 5-second operation to get this radius. That's about how long it takes. It takes me about 5 seconds to figure this out. By now you may have the app, but you can either have an app added to your iPhone or your Android, or you can buy the little calculator. If I was you, the Scale Master Pro is about this size. so it's not very big, but you need it. You're not carrying it with you. If you've got your phone, you probably always have it with you. And the other problem we got is that what if you sit it down and you walk away from it? You've lost it, okay? So it's not that expensive, but it's a pain in the rear end to have to buy this thing many, many times. So I would probably suggest, if you haven't already, you've done it, get the app. And with that, it's a, let's see, 1, 2, 3, 4, 5-stroke operation on that calculator, and you've got the answer. I'm going to show you the mathematical logic behind this, and the calculator does it. You'll find out this is not quite as easy as that 5-stroke operation, but it's still not that difficult. All we're going to do is take this guy and we're going to create a triangle. Right there. This is my radius. That's what I want. This from here to here is half the width of the arc. And from here to here is the radius minus the rise. Okay? So if I looked at that triangle and I pulled it out right here, I would look at something that looked like this. 18 feet. If I take 18 feet and turn this little guy on, 18 times 12, I get 216 inches. Half of that is divided by 2 is 108 inches. So this side is 108 inches. And from here to here is R. Therefore, from here to here is R minus the height of the arc. So this would be R minus 12 inches. So that's that triangle. This guy over here, same thing. Divide him, draw him. I'm going to call this R1 and R2. They're not the same. Hopefully you figure that out. And I've got 9 feet. 9 foot's 108 inches. Half of 108 inches is 54 inches. Therefore, I've got 2 triangles. And we're going to take a break for a second so we can rewind our film.